In this video, we'll talk about trigonometric identities. So, to begin, I want to just say an identity is an equation that is true for all values of a given variable. That is, for example, we know sine squared of x plus cosine squared of x equals 1. That is true for any x that we give to sine squared and cosine squared. So a trigonometric identity is an identity involving trigonometric functions. So we'll go through a few of our trigonometric identities, some of our fundamental trigonometric identities. Then we'll look at how to simplify trigonometric expressions using trigonometric identities. So here is a bunch of trigonometric identities. The first row, the reciprocal identities, we should know from the past. That's cosecant equals 1 over sine, secant x equals 1 over cosine x, those kinds of things. The Pythagorean identities, I think we should also know pretty well by now. Sine squared of x plus cosine squared of x equals 1, and variations therein. Even and odd, hopefully we know, but sine of negative x equals negative sine x, cosine of negative x equals cosine x, and tangent of negative x equals tangent x. The cofunction identities are ones that we haven't talked about extensively, although we've alluded to them in previous videos and explorations of our trigonometric functions. So we know that sine and cosine are related somehow, tangent and cotangent are related, and secant and cosecant are related somehow. And it turns out they're related by transformation. If we factored a negative out of any one of these particular cofunction identities, we would have negative quantity x minus pi over 2. And what that tells us is that sine and cosine can be transformed into one another by flipping it over the y-axis and then shifting it over pi over 2 units to the right. And this is true for both tangent and cotangent and secant and cosecant. I won't spend the time to prove it here, but it's worth going on to Desmos or using your graphing calculator to see that these are in fact related by flipping over the y-axis and a small transformation in the positive x direction. Now, to simplify a trigonometric expression, we can use all of those trigonometric identities to make this cosine t plus tangent t sine t simpler than its current form. So first, with these kinds of things, it's useful to try to write all the trigonometric terms in terms of sine and cosine. So cosine t is already in terms of sine and cosine. Then we have sine t over cosine t and sine t. So now if we multiply things out, we'll have cosine t plus sine squared t over cosine t. And now let's combine like terms, but first we need to multiply cosine t by cosine t over cosine t, in other words 1. So we have cosine squared t over cosine t plus sine squared t over cosine t. And then we see that when we combine these, we have sine squared t plus cosine squared t over cosine t. And since sine squared t plus cosine squared t is by the Pythagorean identity 1, we have 1 over cosine t, and this just equals secant t. So this entire trigonometric expression there can be simplified down to just secant t. This is how we would approach simplifying any given trigonometric expression. So I'll pull up the trigonometric identity so you can see that once more. These are all of our identities. And sometimes you might need to be clever with it. I think with these, the answer isn't always obvious. Sometimes you have to tinker with it a little bit, try something, backpedal, try something different, and eventually you'll be able to simplify. But it's useful to start in terms of sine and cosine. And we'll talk a little bit more about how to prove a trigonometric identity in the next video.